All right, homework day 29 starts out with simplifying a sum or difference of two univariate polynomials. Univariate just means you have the same variables. We all have v's or v squareds in there. Polynomial just means there's more than one term in each expression. This one happens to have three terms. That's one term, there's one, there's a term. So all we're really doing is looking and saying, okay, between these two parentheses we have adding, we're going to add our like terms in our expression. So we have a negative 7v squared and a positive 4v squared. Negative 7 plus 4 is negative 3v squared then. We add or subtract our coefficients, but we leave the exact same variable. Then we do our middle terms. Positive 3v plus 5v, positive 8v, and we need to make sure we put that sign in there since it's not the leading term. And then our constant terms are numbers. Negative 2 plus 1 would be negative 1. So negative 3v squared plus 8v minus 1 would be our answer. Number 2, same thing. If I look at my two polynomials, in between my parentheses it tells me I'm adding those two expressions. So I'm going to add my like terms together. So starting with my y squared, 7y squared plus 6y squared would be 13y squared. Now this one doesn't have any y's, but this one has a negative y, so 0 plus negative y is still negative y. And then my constant terms, my numbers, positive 3 minus 5 is negative 2. Normally they'll do them in descending order from the highest exponent down, but if you put 13y squared minus 2 minus y, it's the same answer. So on the third one, this time it tells us, if my little thing disappears here, that we are subtracting our two expressions. So technically subtracting is adding the opposite, or you can think about it as distributing that negative sign. This part's going to stay the same, 4x minus 6, but then a negative times a positive makes that a negative 2x squared. Negative times a negative makes that a positive 7x. And then a negative times a negative makes that a positive 6. So that I have the opposite of everything that was in the parentheses. Now I can go ahead and combine my like terms, starting with my x squared term. There's only one of them. It's a negative 2x squared. Then my x's, 4x plus 7x would be 11x, so plus 11x. And then my numbers, if I have a negative 6 and a positive 6. Negative 6 plus 6 is 0. They just cancel each other out. So you don't need to put anything down for that. So just negative 2x squared plus 11x. Now 4, 5, and 6, we're doing the same thing, just making them a little longer. We're going to have both adding and subtracting in our problem. So it starts off with negative 7u squared minus 6u minus 9. We're going to add the negative 4u squared plus 2u minus 2, but then we're going to subtract the negative 9u squared plus 2u plus 6. You could write it all the way out across the page. Alex is going to suggest that you line up your like terms so it's easier to find them. So here's how they're going to write this problem. They're just going to start with the first one and rewrite it. Negative 7u squared minus 6u minus 9. Since this has a plus sign in front, all of these should stay the same. Negative 4u squared plus 2u minus 2. This one has the minus, so I have to have the opposite. Negative and a negative makes that a positive 9u squared. Negative and a positive makes that a negative 2u. And then a negative and a positive makes that a minus 6. Now my like terms are all lined up nice and neat, so it's easier to find what we're doing. Negative 7 minus 4 would be negative 11. Negative 11 plus 9 would give me negative 2u squared. Here, if I look at this list, I see I have a positive 2u and a negative 2u. Those are opposites. They're going to cancel each other out because that's 0. So I'm just going to have the minus 6u. And then negative 9 plus negative 2 plus negative 6 would be negative 17. So negative 2u squared minus 6u minus 17. All those are negative. I added and kept my sign. Number 5, same kind of thing. The first set of parentheses doesn't have anything in front, so it's just going to stay the same. Negative 8u squared minus 2u plus 6. This one has the minus in front, so I got to distribute that negative. Negative and a negative makes that a positive u squared. Negative and a positive makes that a minus 7u. Negative and a negative makes that a plus 4, so that I have the opposite of each one of those signs. This one has a plus sign in front, those all stay the same. So I'm going to have a positive 6u squared, a plus 4u, and a plus 8. And then I can combine my like terms. Negative 8 plus 1 plus 6. Well, 1 plus 6 is 7. Negative 8 plus 7 would be negative 1u squared, but we know that we don't need the 1 in front, so negative 1u squared is the same thing as having a negative u squared. Negative 2 minus 7 would be negative 9. Negative 9 plus 4 would be minus 5u. And then 6 plus 4 plus 8, I can just add all those together, plus 18. So negative u squared minus 5u plus 18 would then be my answer. Number 6, same kind of thing there. The first one doesn't have anything in front, we're just going to leave it alone. 4y squared minus y minus 9. This one has a plus sign, so we leave all those the same. Positive 6y squared, a minus 3y, and a minus 3. This one has the negative in front. So this is the tricky, that's the minus 8y squared. Then I have a positive 4y. And then I have a minus 1. So that if I covered that up, they're opposite of all of those what they were. Positive became a negative, negative became a positive, positive became a negative. Combining my like terms. 4 plus 6 is 10, 10 minus 8 is 2y squared. Negative 1y minus 3y. Negative 1 minus 3 would be negative 4. A negative 4 plus 4 is a 0y. So those all just cancel each other out. We're not going to put anything in between. And then here, negative 9 minus 3 minus 1, all of those are negative. I add and keep the sign, so minus 13. So 2y squared minus 13 would be my answer. Seven, 8, and 9, we are now using the distributive property. The distributive property is used to remove the parentheses by multiplying the 2z to the 6 times each of these two terms. So I'm going to take my 2z to the 6 times my 9z to the 8th. If you remember when we multiplied those, we multiplied the front numbers, and when we multiply with the same base, we add the exponents. So 2 times 9 is 18. Z to the 6 times z to the 8th would be z to the 14th, because 6 plus 8 is 14. Then we're going to take 2z to the 6 times 7z. So positive 2 times a positive 7 is a positive 14. Z to the 6 times z to the 1st. Adding that, I get z to the 7th power. Those are not going to be like terms because they have different variables, so I can't add them together. I just write it down as 18z to the 14th plus 14z to the 7th. So number 8, same kind of thing using my distributive property. 2w squared times 5w to the 5th. 2 times 5 is 10. I add my exponents, so 2 plus 5 would be w to the 7th when I take w squared times w to the 5th. Here, I'm going to multiply. 2w squared times negative 3. Well, 2 times negative 3 is negative 6, and I'm still going to have that w squared. 2 plus no more is still 2. So I get 10w to the 7th minus 6w squared. Number 9, we're still using our distributive property to remove the parentheses. This time they just put the value on the end, but same kind of thing. I'm going to start by taking my 4x to the 4th times my 9x to the 5th. 4 times 9 is 36. X to the 4th times x to the 5th, I add my exponents, so x to the 9th. Then negative 3x squared times 9x to the 5th. Negative 3 times 9 is negative 27. X squared times x to the 5th, I add my exponents, so x to the 7th. And then 3 times 9x to the 5th. 3 times 9 is positive 27. Make sure you put the plus sign in front. And although that doesn't have any x's, you still have the x to the 5th there, so we can't leave that out. And so 36x to the 9th minus 27x to the 7th plus 27x to the 5th is going to be my answer. 10, 11, 12 doing the same thing, but this time it's going to be multivariate, so you're going to have more than one variable. So number 10, again, thinking about it the long way of using my distributive property, I'm going to take this times this first. So 3y to the 6th, z to the 3rd times negative 8yz squared. 3 times negative 8 is negative 24. I add my exponents, so y to the 6th times y would be y to the 7th, z to the 3rd times z squared, z to the 5th. And then I'm going to multiply those two terms together, so 9y to the 4th times negative 8yz squared. A negative 9 times a negative 8 is a positive 72. Y to the 4th times y is y to the 5th. And even though that doesn't have a z, this has a z squared, so I'm still going to have the z squared on the end. So negative 24 y to the 7th, z to the 5th, plus 72 y to the 5th, z squared. Number 11 then, using my distributive property, I'm going to multiply this part out first. Negative 3 times a positive 5, negative 15. B to the 6th times b to the 3rd, I add my exponents, so b to the 9th, and then I have a c here, no extra c's there, so I still have that c. So negative 15, b to the 9th, c is my first term. Then my middle term, negative 3b to the 6th c times positive 2b to the 4th c to the 5th. So negative 3 times a positive 2 is negative 6. b to the 6th times b to the 4th. I add my exponents, b to the 10th, and then a c times a c to the 5th. Again, 1 plus 5 gives me 6. So my middle term, negative 6, b to the 10th, c to the 6th. And then my third term, I have negative 3 times negative 8, positive 24. I have a b to the 6th, no extra b's, so I still have b to the 6th. And then I have a c times a c to the 5th. I add those together, so c to the 6th. So I get a great big long answer. Negative 15b to the 9th c minus 6b to the 10th c to the 6th plus 24b to the 6th c to the 6th. And number 12, using my distributive property again. 3ac to the 6th times 9c squared. 3 times 9 is 27. I have an a, and then c to the 6th times c squared, c to the 8th. 3ac to the 6th times 7a to the 4th. 3 times 7 is a positive 21. A times a to the 4th is a to the 5th. C to the 6th with no extra c's, still c to the 6th. My a sort of looked like an a. And then 3ac to the 6th times negative 8. 3 times negative 8 would be minus 24, but I still have the ac to the 6th. So 27ac to the 8th plus 21a to the 5th, c to the 6th, minus 24ac to the 6th. (13, 14, and 15) say multiplying binomials with leading coefficients of 1. Binomials just mean you have two terms. X plus 5 is a binomial, x minus 2 is another binomial. says the leading coefficients are 1 because you just have a 1x and a 1x. You don't have any 2's or 3's in there yet. So when I multiply binomials, they do what they call foiling. Multiply the first two together, multiply the outside pair together, multiply the inside pair together, and multiply the last two together. So the long way of doing this, if I do the first two, I'm taking the x times the x. X times x is x to the second power. Adding my exponents, 1 plus 1 is 2. Or anything times itself makes it squared. Doing my outside pair together, my outside pair would be the x times the negative 2. In algebra, when you take a variable times a number, you just put the number in front of the variable, no sign in between, so x times negative 2 is just negative 2x. Then doing my inside pair together, I have a positive 5 times x, so I'm going to get a positive 5x. I put that sign there because I know normally I'd be writing this all out in a row and I need the signs in between. And then my last pair, a positive 5 times a negative 2. Positive times a negative is a negative, so I get minus 10. So really what I did is I took this x times both of these two terms and then the 5 times both of those two terms. Now when you have your list, these two terms here are going to be like terms. Negative 2x and a positive 5x have the exact same variable. I can combine them. Negative 2 plus 5 is positive 3x. So my answer looks like this, x squared plus 3x minus 10. They happen to call that a trinomial because there's 1, 2, 3 terms. So normally I don't write all of that down, but just to explain what foiling is, I put that there. Normally I just do this. I start out and I say, okay, first one's w times w. W times w is w to the second power. W times my plus 4. A variable times a number, I put the number in front of the variable and I include that sign, so plus 4w. Negative 1 times w. Normally that's negative w, but since I'm doing my work, I can put the 1 in there if I want to, just to remind me that that's a negative 1w. My answer, I wouldn't want the 1 there. And then negative 1 times a positive 4. Negative times a positive is a negative, and 1 times 4 is 4. So keep in mind there, you're multiplying all of those together. Now you're going to combine your like terms, so now you're doing your adding and subtracting. So my answer, I'm going to have the w squared. 4w minus 1w is plus 3w, and then the minus 4 on the end. And so w squared plus 3w minus 4 is my answer. And the last one here, number 15. Again, we're multiplying binomials, so I'm going to FOIL it out. U times u, u to the second power. U times negative 7 on the outside, negative 7u. Plus 5 times u on the inside, plus 5u, and a positive 5 times a negative 7. Positive times a negative is a negative, and 5 times 7 is 35. Again, my middle two terms will be like terms. I'll be able to combine those. So u squared, negative 7 plus 5 would give me negative 2u minus 35. And there's my answer. So when I multiply two binomials, they do what they call foiling, and we'll do a bunch more of that on the next sheet.